Hi, so today I'm going to be doing the CIE AS Chemistry February-March 2025 paper 12. Question number 1. A Boltzmann distribution for a sample of reacting gas at a constant temperature is shown. The activation energy represented by this for the reaction is marked, so it's right here. Point X, which is right here, shows the number of particles whose energy is equal to the activation energy. The temperature of the sample of gas is decreased. The shape of the distribution curve changes. Which point could show the number of particles whose energy is the same as the activation energy at the new temperature? So since we're at the same activation energy, which is here presented on the x-axis, the particles must be along this line. Because along this line is all the particles that have the activation energy. So we can already eliminate options A and options C. Now, the two options we're left with are B and D. One is lower, one is higher. So let's take a look at what happens when the temperature decreases. So when we lower the temperature, the particles would lose kinetic energy, so they're going to move a lot slower and with less energy. Therefore, the number of particles with the activation energy is also going to decrease, because remember, the activation energy is the energy needed for a successful collision to take place. Therefore, our answer must be D. Question number 2. Crystals of copper nitrate are prepared by adding an excess of malachite to nitric acid. The formula of malachite is as follows with a molar mass of 221 grams. 12 grams of malachite is added to 30 centimeters cubed of 1.50 moles per decimeters cubed of nitric acid. Which mass of malachite is left unreacted when the reaction is complete? Now, from the fact that there is some left unreacted, we can sort of infer that the nitric acid is going to be in excess. Now, if we take a look at the formula, nitric acid has the formula HNO3 and copper nitrate has the formula of 1 copper and 2 nitrate polyatomic ions. So from this, each copper requires 2 nitrate ions. However, in the formula we have 2 copper ions. That means we require 4 nitrate ions. Therefore, we know that our molar ratio of our malachite to nitric acid is going to be 1:4. That is because we are provided with 2 copper from malachite, and each nitrate ion provides 1, and we need 4 of them. So the first thing we're going to do is we're going to calculate the number of moles of nitric acid. So we're given that there are 30 centimeters cubed of 1.5 moles per decimeter cubed, and our formula states that the number of moles is equal to the concentration times the volume. So we're just going to do 1.5 times 30 over 1,000 because we want our units to be the same. So to go from centimeters cubed to decimeters cubed, you must divide by 1,000, and we end up with 0.045 moles. Now, the number of moles of malachite reacting are going to be 4 times smaller than the number of moles of nitric acid reacting. So basically we're going to take our 0.045 moles and divide it by 2 to end up with 0.01125 moles. Now, to figure out the number of moles of malachite left, first we need to find the number of moles of malachite to begin with. So there are 12 grams and it has given us a molar mass of 221. So if we type that into the calculator, we get 0.0543 moles. So what we're going to do is we're going to subtract 0.01125 from 0.543. And we end up with 0.043. And now we need to figure out the mass left, and as we know, the number of moles is equal to mass times mR, so the mass is equal to the number of moles times the mR. So we're just going to take the number of moles left, which is 0.043, and multiply it by mR, which is 221, and we end up with 9.51 grams, so the answer must be D. Question number 3. X and Y are elements from the same group of the periodic table. The 5th to 9th ionization energies for X and Y are shown below. Which row identifies the elements? And they've given us a table, and they've given us options, of course. So if we take a look, we have our ionization energy up here of 5th, 6th, 7th, 8th, and 9th, and our elements X and Y on the side here. Now, if you take a look, the trends are increasing, and that's something that we expect, but there is a very large jump between the 7th and the 8th ionization energy for both, and from this we can conclude that both elements are in group 17. This is because the large jump in the ionization energy means that electrons are now being removed from a shell closer to the nucleus, and because it's between the 7th and the 8th, that means the 7th electron was the last electron in the outer shell, so the outer shell must have had 7 outer electrons. So from this I can already eliminate options A and D because argon and neon are in group 18 and not 17. Now it's asking us to determine whether it is fluorine or chlorine that are, which way round it is. So the big difference between element X and element Y is overall element X has higher ionization energies. Now, because they're both in group 17, we know that as we go down the group, our shielding increases. What this means is our outer electrons are going to be further and further away from the nucleus. There's going to be weaker forces of attraction as you go down the group. So that means the ionization energy decreases because remember the ionization energy is the energy needed to remove outer electrons. And if the electrons are weakly attracted to the nucleus, it's going to require less energy to remove them. So what this means is fluorine here is going to have a higher ionization energy than chlorine. Therefore, our answer must be C because element X is the one with the higher ionization energy. Question number 4. An ion with a charge of 2- contains 10 electrons and 14 neutrons. What is its nucleon number? So the nucleon number is the number of neutrons plus the number of protons. So the number of neutrons as given is 14. The number of electrons after it has become an ion is 10. And because it has a charge of 2-, it must mean it gained 2 electrons. So before that it had 8 electrons because that is 10 minus 2. Therefore, the number of protons is equal to the number of electrons when an atom is neutral, when it's not an ion. So it's going to be equal to the before, which is 8. Therefore, we have 8 protons and 14 neutrons. And when we add those two together, we get a nucleon number of 22, so the answer must be B. Question number 5. The structure of the hormone histamine is shown. Which row contains the bond angles X, Y, and Z in the correct order from the smallest to the largest? So, you don't have to be familiar with histamine as a structure, but you're supposed to be able to recognize different shapes. And if we take a look, I've highlighted the 3 sections in different colors to make things a bit simpler. And if we look at the simplest part, it would probably be this middle section, which is right here. So the carbon atom here is bonded to 4 other atoms. This forms a tetrahedral shape which has a bond angle of 109.5 degrees approximately, and this is because there are 4 bonding pairs and 0 lone pairs. Now if we look at the yellow part next to it, right over here, we actually have a trigonal pyramidal structure. That is because there are 3 bonding pairs and 1 lone pair, and the lone pair contains 2 electrons, of course. That is because nitrogen is in group 15, so it has 5 outer electrons, and it shares 1 with each of these 3 molecules, and there are 2 remaining in a lone pair. Therefore, we have the trigonal pyramidal structure, and because there are 4 pairs, you have that tetrahedral shape, but because one of them is a lone pair, we get minus 2.5 degrees from the tetrahedral bond angle, which is 109.5 degrees, which leaves us with 107 degrees. Then the last structure would be this pink one right here, and it is trigonoplanar. It is an atom bonded to 3 other atoms. So 3 bonding pairs and 0 lone pairs. So we have our trigonal planar, and this tends to have a bond angle of 120 degrees. So, if we arrange them in order of bond angles, our largest bond angle is 120 degrees, then 109.5 degrees, then 107 degrees approximately. So this is actually in the following order: X, Y, then Z. Therefore, answer must be A. Question number 6. When an organic acid reacts with an alcohol, a reversible reaction takes place, producing an ester and water. 0.4 moles of acid and 0.3 moles of alcohol are mixed and are allowed to stand at 25 degrees Celsius. At equilibrium, we have 0.2 moles of ester. What is the value of the equilibrium constant under the conditions used? So Kc is going to be the concentrations of the ester and the water produced, so the products, over the concentration of the reactants multiplied by each other. They're all to the power 1. We don't actually have to write 1 because the reaction is in a 1 to 1 to 1 to 1 ratio. So if we just fill in the details, now I use the ICE method, so the initial, the change, and the equilibrium values for moles. So I have 0.4 moles of acid at the start and 0.3 moles of alcohol. We can assume that there are 0 moles of ester and 0 moles of water because the alcohol and acid haven't reacted just yet. We did say that this is in a 1 to 1 molar ratio, which means that the acid is in excess. It says there are 0.2 moles of ester at equilibrium, so that means there's a change in 0.2 from 0. Because there is a 1 to 1 to 1 to 1 molar ratio, the change is equal in all 4 of them. So 0.2, 0.2, 0.2. Now the number of ester moles has increased by 0.2, so that means the reactants must decrease. So the number of moles of alcohol at equilibrium are going to be 0.3 minus 0.2, which is 0.1, and acid is 0.4 minus 0.2, which is 0.2. And obviously the water moles, because it's a product, would have increased by 0.2 as well. So the values we are left with for the moles at equilibrium are as follows, and if we substitute that in, we get 0.2 times 0.2 over 0.2 times 0.1. Now, these are the number of moles and not the concentrations, but because there is an equal number of brackets at the top and at the bottom, and the powers are equal as well, the volumes cancel out. So it would initially be like this. And you find that the volumes cancel out, so we don't actually need to know the volume for this, and we will still get the same answer. Now, when we type this into the calculator, we end up with 2, therefore the answer must be C. Question number 7. Information about 2 substances is given below. Which row describes the structure and the bonding in substances P and Q? So let's take a look at substance P first. It's good when it's solid. The electrical conductivity is good when solid and when molten. When solid infers that it is a metal. If it was only in molten, then it would be ionic, because in an ionic lattice, ions are fixed, but in molten solution, they are free to move. But in solid metals, there are delocalized electrons. Here it says the effect of adding water reacts vigorously to produce an alkaline solution. So metals like magnesium, again, because we've already deduced that it's a metal, can form alkaline solutions like magnesium hydroxide or calcium hydroxide, for example. And the melting point is fairly high at 454 Kelvin. If we take a look at substance Q, it doesn't conduct at all. From this, we can deduce that it's molecular because it's neither ionic nor metallic. Then it says it reacts vigorously to produce an acidic solution. So this could be something like phosphorus. It forms phosphoric acid. Sulfur forms sulfuric acid. These are all simple molecular substances. And the melting point is lower than that of a metal because they're simple molecules. Therefore, our answer is going to be A, because P is metallic here and Q is simple molecular. Question number 8. An excess of zinc reacts with X centimeters cubed of 2 moles per decimeters cubed of hydrochloric acid. The gas produced is dried and collected. The gas occupies 1.534 decimeters cubed at 101,000 pascals and 293 Kelvin. The gas produced behaves as an ideal gas. What is the value of X? So whenever there's a mention of ideal gases, we're always going to be using the formula PV equals nRT. Now we actually have our V volume, our P pressure, and our T temperature. Our R value is known, it is always 8.31, and our only missing value is Rn, our number of moles, so I've rearranged it so that N equals PV over RT. If we take a look at the units for each of them, they're all correct except the volume. It's in decimeters cubed, so to go from decimeters cubed to meters cubed, the way it should be in meters cubed. You're going to have to divide by 1,000. So we just need to keep that in mind while we're solving. So if we take a look at the equation here, 1 mole of zinc reacts with 2 moles of hydrochloric acid to form zinc chloride and hydrogen. So zinc to hydrochloric acid is in a 1:2 molar ratio. Also something we need to keep in mind. So the first thing I'm going to do is I'm going to calculate the number of moles of zinc because that's all we can do so far. So it's going to be equal to the pressure times the volume over R times T, which equals pressure is 101,000 times 1.534. Remember to divide by 1,000 to convert, and times by 8.31 times 293. We end up with 0.0636. So the number of hydrochloric acid, the number of moles of it, are going to be 2 times the number of moles of zinc. So we're just going to take that number and multiply it by 2, and we get 0.127 moles. Now to find the volume, we've been given the concentration of 2 moles per decimeter cubed. And we know that the volume equals to the number of moles over the concentration. We've derived this from the concentration is equal to the number of moles divided by the volume. So really, we're going to take that number and we're just going to divide it by 2. And we'll end up with the same number we started with, coincidentally. And now we end up with 0.0636 decimeters cubed. If you take a look at our answers, they're all in centimeters cubed, so we actually have to convert them to centimeters cubed. To go from decimeters cubed to centimeters cubed, you need to times by 1,000. And so we'll end up with 63.6 centimeters cubed. So the answer must be C. Question number 9. An aqueous solution of hydrogen peroxide is placed in a flask and decomposes as shown. This is the equation for it. The total volume of oxygen gas evolved is 180 centimeters cubed after 90 seconds, measured under room conditions. The rate of the reaction is calculated using the equation shown, where the rate is the change in moles of hydrogen peroxide over time. What is the average rate of the reaction measured in moles per minute over the duration of the experiment? So we need the moles of hydrogen peroxide and we need the time in minutes. So we know that 180 centimeters cubed of oxygen gas has evolved. We know that 1 mole of any gas at room temperature occupies 24 decimeters cubed of volume. So if we can get that into decimeters cubed, we can kind of figure out how many moles of oxygen we have and then how many moles of water we have. Hydrogen peroxide we have. So to go from centimeters cubed to decimeters cubed, we need to divide by 1,000. So we actually have 0.18 decimeters cubed of oxygen. So the moles of oxygen is 0.18 divide 24 decimeters cubed, which is 7.5 times 10 to the negative 3. So the moles of hydrogen peroxide are going to be double that because they are in a 1:2 molar ratio. So 7.5 times 10 to the negative 3 times 2, which gives us 0.015. And now we have the moles, and we need the time. Time is given to us in seconds. To go from seconds to minutes, we need to divide by 60. So our minutes is equal to 90 over 60, which is equal to 1.5. then our rate is going to be equal to 0.015, which is the number of moles, divided by 1.5, which is equal to 0.01. Therefore, our answer is D. Question number 10. Methanol is manufactured by reacting carbon dioxide and hydrogen together. This is the equation for that. What increases the equilibrium yield of methanol in this process? So this is our methanol. Delta H is negative, therefore the forward reaction is exothermic. Our first option is increasing the pressure. So pressure is to do with the number of moles on each side. So 1 mole of carbon dioxide, 3 moles of hydrogen, total number of 4 moles on the left-hand side, 1 mole of methanol and 1 mole of water, so a total number of 2 moles on the right-hand side. If we increase the number of moles, the equilibrium is going to shift to the right in the direction of methanol to increase the number of moles. To decrease the number of moles. Therefore, we'll have more methanol, so the answer must be A. But to discuss the other options, so B here, we added an excess of steam. Steam is just H2O in its gas form. If we do increase the number of steam, it's going to shift to the left. And it says, here in C, it says adding a catalyst. Adding a catalyst increases the forward and the backwards reactions equally, the rate at which they take place, so there will be no change in the yield. Then D, it says increase the temperature. Well, if you do increase the temperature, the equilibrium is going to shift to the left in the endothermic direction to lower the temperature. So the only correct answer is A. Question number 11. The equation for a reaction of KClO3 is shown below. Which row is correct? Whether or not it's a disproportionation reaction, and determining the oxidation number of chlorine in KClO4. So, in a disproportionation reaction, oxidation and reduction take place for the same atom. So in this case, it should be chlorine because it's present in both, or potassium because it's present in both. However, we know that potassium is always +1 generally, so it's probably chlorine that is going to undergo the disproportionation if it does. So what we're going to do is we're just going to deduce or figure out what the oxidation states of chlorine are in each of our compounds. So in KClO3, maybe use a different color. K is +1, potassium is +1, oxygen is -2, but there are 3 of it, so it's overall -6. So it's a compound with no charge, so overall we should have a charge of 0. So +1 -6 plus x equals 0. Here x must equal 5 for it to balance. Just move the 6 and the 1 to the other side. Here potassium is +1, so chlorine is -1 because there's no overall charge of 0. In KClO4, potassium is +1, oxygen is -2, but there's 4 of them, so -8. So there's an overall charge of 0, so +1 plus x -8 equals 0. X must equal 7. If you take a look, the oxidation state of chlorine has gone from 5 to -1 and to 7. There's been an increase and a decrease in oxidation state for the chlorine atom. So yes, this is a disproportionation reaction. We can already eliminate option C and D, and we deduce that the oxidation number of chlorine in KClO4 is +7. Therefore, our answer is B. Question number 12. A student mixes 25 centimeters cubed of 0.1 moles per decimeter cubed of sodium hydroxide solution with 25 centimeters cubed of 0.1 moles per decimeter cubed of hydrochloric acid and records a temperature rise of 2.5 degrees Celsius. What is the enthalpy change of the reaction per mole of sodium hydroxide? Okay, so with these, we use Q equals mc delta T to calculate the amount of energy released, and delta H, which is the enthalpy change, to calculate, and we use the energy released divided by the moles of the limiting, if there is one, to find our enthalpy change. a few things to just look out for. Temperature rise or temperature changes in general, it does not matter what units we use because it is change, and change is proportional. Another thing to note down is it is a temperature rise, so we will have a negative value because releasing energy will give a negative delta H. Another thing to look out for is when we're calculating our enthalpy change, we must divide by 1,000 because our energy released is in joules, but enthalpy change is in kilojoules. So let's actually start calculating. So what is our M here in this equation? What is our M? Our M is going to be our volume, our total volume, which is 25 centimeters cubed of each. So our M is going to add up to equal 50. C is known, it's always 4.18. Our T is our temperature change, which in this case is 2.5. So if we calculate our Q, we're going to get 50 times 4.18 times 2.5, which equals 522.5. Now for the second equation, we need our number of moles, which is N. That is the number of moles of the limiting reagent. Now sodium hydroxide and hydrochloric acid react in a 1-to-1 molar ratio, and they're both present in the same amounts, so we can use either or. So 25 centimeters cubed, the number of moles is equal to the concentration times the volume. So 25 times 0.1, but because the 25 centimeters cubed are in centimeters cubed and not decimeters cubed, we're going to have to divide that by 1,000, and we will end up with 2.5 times 10 to the negative 3. And so our delta H is going to be equal to 522.5 divide 1,000 to turn it into kilojoules times 2.5 times 10 to the power negative 3, which leaves us with 209 kilojoules. But it is of course negative because it is exothermic. Therefore our answer must be A, not to be confused with C. Question number 13. Carbon monoxide and methanol react together to form ethanoic acid. The equation is as follows. Standard enthalpy changes of combustion are given in the table below. What is the value of the enthalpy change for the reaction between carbon monoxide and methanol? So any enthalpy change takes the following route. I've drawn the arrows in blue. And when we're given enthalpy changes for combustions, we draw arrows downwards always. Now for formation it's upwards, but for combustion it's downwards. And like I said, we're supposed to follow this pathway. Any arrow that goes against the direction, then we have to multiply it by -1. So this arrow here must be multiplied by -1. If we take a look, all of them are 1 mole each. So really what's going on is it's negative 283 facing downwards, negative 726 facing downwards, and negative 874.1 facing downwards. We would add them all together, but this one is facing the opposite direction, so really we're going to times this by -1, and we're going to end up with 874.1. Now we can add them all together, so negative 283 minus 726 plus 874.1, which equals negative 134.9. Therefore, our answer is B. Question number 14. Copper reacts with nitric acid. Under certain conditions, the products are copper nitrate, water, and an oxide of nitrogen. 3 moles of copper react exactly with 8 moles of nitric acid. What is the oxidation state of nitrogen in the oxide produced? So what I've done is I've basically just written out the equation with all the information they've provided. And now what I'm going to do is I'm going to try and figure out the rest. So 3 moles of copper react with 8 moles of nitric acid. Now copper is only present here, so that means I'm going to add 3 moles right here. And therefore we will actually end up with 6N from here. And we're going to end up with 3 times 2 times 3, which is 18 oxygen. Over here we have 8N, we have 8 hydrogen, and we have 24 oxygen here. So hydrogen's only present here in water. So we need 4. Therefore, there are 4 oxygen here. In total, these two give us 22 oxygens, but we need 2 more oxygens. Therefore, we need to add a 2 here. And now we have a total of 8N, which is exactly how much we need. So our X is actually 1. And therefore, our oxidation state is going to be +2 because our oxygen is -2. So the answer must be B. Question number 15. All the reactants and products of an exothermic reaction are gaseous. Which statement about the reaction is correct? So if we are talking about an exothermic reaction, then the enthalpy change must be negative. So I can already eliminate options B and D. Then what they're referring to are the total bond energy of the products and the reactants. Now, if you can recall Bendomax, then this would help you out. In endothermic reactions, the total bond energy of the reactants is greater because endothermic reactions involve absorbing more energy to break the reactants than is released from forming the products. However, in an exothermic reaction, the products actually have a total bond energy. So in other words, more energy is released from forming those bonds than is absorbed breaking the reactants' bonds. Therefore, the answer must be C. Question number 16. Propene, hydrogen cyanide, and carbon dioxide each contain pi bonds. Which molecules contain 2 pi bonds? Now, before we start, I think it's really important to be able to distinguish between a sigma and a pi bond. So there are 3 scenarios I have given down below. The first scenario is a single bond between 2 atoms. This only contains a sigma bond. A double bond contains a sigma bond and a pi bond, and a triple bond contains a sigma bond and 2 pi bonds. Now let's look at the 3 compounds they have given us. They've given us propene, carbon dioxide, and hydrogen cyanide. Propene has 1 double bond, which must mean there's only 1 pi bond present. Therefore, anything that includes propene is incorrect, so I can eliminate B and C. Then if we look at carbon dioxide, we have 2 double bonds, so a pi bond per double bond. And then hydrogen cyanide has a triple bond, so there are 2 pi bonds in here. Therefore, both of these have 2 pi bonds. So the answer isn't D because it's not just hydrogen cyanide. Therefore, our answer is A. Question number 17. Q, R, and S are consecutive elements in period 3 of the periodic table. Element R has the highest first ionization energy and the lowest melting point of the 3. So they're consecutive and they've arranged A to D in as consecutive elements, so there's nothing we can eliminate. But if we look at column R, basically all we have to really do is find out which one has the highest ionization energy and the lowest melting point. So as we go across period 3, what happens is the atomic radii actually decrease. The reason for this is because the shielding remains the same or similar. However, the proton number increases. Therefore, the outer electrons are more attracted to the nuclei. So the ionization energy actually increases. So out of all these 4 options, P is the furthest across. Therefore, the answer must be D. It also does have the lowest melting point. Phosphorus is simple molecular. And silicone is giant covalent. Aluminium and magnesium are metallic, so they're rather large, while phosphorus is very small. Question number 18. A reaction scheme for a group 2 metal is shown. Which row is correct as M descends group 2 from magnesium to barium? So if we take a look at the table, we're referring to the solubility of Y in water and Z in water. Here is Y and here is Z. So Y and Z are after the metal has reacted with oxygen to form an oxide, and then reacted with water, and then reacted with sulfuric acid. Our reaction with water is going to produce hydroxides, and with sulfuric acid is going to produce sulfates. Now, it is common knowledge that down group 2, oxides become more soluble and sulfates become less soluble. Therefore, the answer must be C. Question number 19. U, V, and W represent different halogens. The table shows the results of 9 experiments in which aqueous solutions of U2, V2, and W2, so basically the diatomic molecules, were separately added to separate aqueous solutions containing U-, V-, and W- ions. Which row contains the ions U-, V-, and W- in order of their decreasing strength as reducing agents? Okay. So, the weakest reducing agent is going to be the one that is displaced the least, but displaces the most. So this is because if we go from V- to V2, this is an example of oxidation. A reducing agent itself is oxidized. Therefore, if V- remains as V- and it's not oxidized, then it is a weak reducing agent. So we can look at this vertically or horizontally, but I think we should just look at it vertically, so up, down. V- is not displaced in all 3 reactions. W- is displaced in 2, and not displaced in 2, and U- is not displaced in 1. Therefore, V- is our weakest and U- is our strongest. Therefore, the answer to this question must be B. Question number 20. J is either MgCl2 or AlCl3. K is either SiO2 or SiCl4. Which row is correct? So they just want us to find the identities of J and K. So let's take a look at J. First, they added drops of aqueous sodium hydroxide, and we get a white precipitate as we would expect with both. But then it's added in excess and the precipitate dissolves. From this, we can be certain that this is AlCl3 because MgCl2 is insoluble in excess and it would just remain a white precipitate. So we can already eliminate C and D. Then we can move on to K. So for K we added water and we had misty white fumes and a white precipitate in a solution with a pH less than 7. From this I can sort of infer that these white fumes might be hydrogen chloride gas. And what way would we get that unless there are chlorine atoms present in the compound? So K must be SiCl4, so the answer must be A. Now to just clarify a few more things, this white precipitate would be the silicon dioxide precipitate formed. The pH would be less than 7 because the hydrogen chloride formed can dissolve in the water to give an acidic solution. And with silicon dioxide, it is not going to react with water at all. So we don't see a white precipitate, we won't see an acidic solution, but it itself is an acidic oxide. Question number 21. River water in an agricultural area contains ammonium carbonate, hydrogen carbonate, chloride, and nitrate ions. This water is treated by adding a calculated quantity of calcium hydroxide. What is precipitated from the river water when calcium hydroxide is added? And we have 4 options, of course. So our calcium hydroxide has this formula and it contains calcium 2 plus ions. Now, with the ammonium ions, to begin, we wouldn't have any precipitate formed from this because ammonium ions are cations and so are calcium ions. So we're not going to have a precipitate. When it comes to chloride and nitrate ions, they are both soluble in the water, so we're not going to have any precipitate form. However, our carbonate ions and our hydrogen carbonate ions will react with our calcium ions to form calcium carbonate. So the answer must be B. Question number 22. 4 atmospheric pollutants are listed: nitrogen oxides, carbon monoxide, unburnt hydrocarbons, sulfur dioxide. Which pair of pollutants react to form peroxyacetyl nitrate, also known as PAN? Okay, so you should be familiar with the process, but basically what happens is unburnt hydrocarbons under UV light radiation can actually form free radicals and also aldehydes. Now, when aldehydes react with oxygen, right here, they can form the peroxyacetal radical. Peroxyacetal radicals can react with nitrogen oxides, or nitrogen dioxide to be specific, to form our PAN. Therefore, in order for all of these to take place, we need 1. Unburnt hydrocarbons to form the aldehydes, 2. Nitrogen dioxide to react with the peroxyacetal radical formed from the reaction between the aldehydes and the oxygen. So our answers are 1 and 3, therefore the answer is A. Question number 23. Which graph correctly describes a trend found in group 17? This is group 17 and the 3 elements that are used throughout all of these graphs. So if we take a look at graph number A, it says the bond length decreases as you go down the group, but instead it actually increases, because as you go down the group, the shielding increases, which means the radii also increase. As the radii increase, the bond length is going to increase as well. However, this displays a decreasing trend. The bond length increases because the larger the radii, the further apart the two atoms can actually be. So it's definitely not A. If we take a look at C, it says the boiling point decreases as you go down the group, but this is also incorrect because chlorine is actually a gas and iodine is a solid. That is also due to the fact that the strength of the intermolecular forces increases as you go down the group, so the answer must be B, but we'll take a look at as to why in a bit more detail. If we look at option number D, it says the bond energy increases as you go down the group with hydrogen halides. However, that is not the case, because if we go back to our explanation for A at the start, the bond length increases. Therefore, less energy is needed to overcome a hydrogen halide bond as you go down the group. However, when it comes to B, the strength of the van der Waals forces does indeed increase. That is because as you go down the group, the proton number increases, therefore the number of electrons increases, therefore the intermolecular forces are going to increase as well, due to the presence of more electrons. Question number 24. Gas M is produced when ammonium chloride is heated with calcium oxide. Which row is correct? So what is the type of the reaction and what is the identity of M? So I've written out the equation below, and the gas that is produced here is actually ammonia. So we can eliminate options B and D. A and D. And then when it comes to the type of reaction that's taking place, is it redox or is it acid base? Now, if it were a redox reaction, then the oxidation states would differ. But if we calculate the individual oxidation states throughout, you'd find that they don't differ. So this must be an acid-base reaction. So the answer must be C. The acid here is the ammonium chloride, and the calcium oxide acts as a base because it is a basic oxide. Question number 25. Two nitrates decompose on heating according to the equations shown. 1 mole of each nitrate is heated separately. The gas produced in each reaction is bubbled through sodium hydroxide. The volume of any gas that does not react with sodium hydroxide is then collected and measured. Which nitrate shows the greater percentage loss in mass and the greater volume of gas collected? Okay, so our two nitrates are lead nitrate and ammonium nitrate. For lead nitrate, the two gases produced are nitrogen dioxide and oxygen. For ammonium nitrate, the two gases produced are nitrogen and oxygen. Now, of the 3 different types of gases produced, nitrogen dioxide reacts with sodium hydroxide while oxygen and nitrogen do not. Therefore, for lead nitrate, we will have 1 mole of oxygen, a volume of oxygen collected, and then for ammonium nitrate, we'll have 2 moles of nitrogen and 1 mole of oxygen, overall 3 moles of gases. Therefore, ammonium nitrate will have a greater volume of gas collected, so we can eliminate options B and D. Then when it comes to the greater percentage loss of mass, what we can do is we can carry out brief calculations for this. So, this is to be here. I've provided the molar mass. I've multiplied the lead nitrate's molar mass by 2 and the lead oxide's molar mass by 2, and I've done the same with the ammonium nitrate and the water produced. I've only figured out the masses for the solids and the liquids because any gases produced will leave and escape, contributing to the loss of mass. So what I've done is, what we can do is we can calculate how much of solid or liquid is obtained as a percentage of the original masses we had to begin with. So for lead nitrate, 446 out of 662 leaves us with 67% of our original mass obtained. With ammonium nitrate, 72 out of 160 gives us with approximately 45% of our original mass obtained, meaning with lead nitrate we've obtained more mass, therefore ammonium nitrate has had a greater percentage loss of mass. Therefore our answer is A. There is another method we could have done. We could find how much of gas has been produced instead, but as a percentage of the original mass, but it works either way. Question number 26. Organic compound X has the empirical formula C2H4O. Compound X is reduced by LiLH4 but not by NaBH4. What is compound X? So if something cannot be reduced by NaBH4 but can be reduced by LiAlH4, it must be an acid, not an aldehyde, and not a alcohol, and not a ketone. So we can already eliminate options B and C because ethanol is an aldehyde, butanol is an alcohol. Then we're left with two acids. I've wrote down the empirical formulas for each of them on the side, and because they've given us our empirical formula, the only one with the same empirical formula is D. Therefore the option must be butanoic acid. Question number 27. What is the mechanism of the reaction of hydrogen cyanide with propanone? So propanone is a ketone, therefore ketones undergo a nucleophilic addition reaction, so the answer must be C. Question number 28. Which compound may be synthesized from an alkene with the formula C4H8 by an addition reaction? Now what's important to understand is regardless of wherever the double bond is, when it breaks, the two carbon atoms that were once connected by a double bond will have two atoms attached to each other, and these two carbon atoms are adjacent to each other. So the atoms that are added, the iodine, the bromine, they both also have to be adjacent to each other. If we look at option A, 1,1-dibromobutane suggests that the first carbon has two bromine atoms attached, which isn't possible. They have to be on adjacent carbon atoms, not the same carbon atom. So options C and D are also incorrect, and the only correct option is option B. Question number 29. The structure of compound G is shown. Compound G undergoes addition polymerization, which diagram shows the repeat unit of the polymer formed. So if we take a look at our monomer, what happens in addition polymerization is the double bond breaks right here. So the double bond between two carbon atoms, that is, so not this one and not this one. So what takes place is this double bond breaks, and then we get a big long line here and a big long line here, and this will just be a single line. If we take a look at our options, the model that fits that is option number C. Question number 30. Compound T is tested with 3 reagents and gives the results shown. What is compound T? So it's given the reagent and the result. The first thing here is 2,4-DNPH gives an orange precipitate. This is a positive result. That means there is either an aldehyde or a ketone present. With Fehling's reagent, there is no reaction, so it's not an aldehyde. Then it says with acidified potassium dichromate, there is no reaction. This means either this is an acid or a ketone. So if we take a look at our options, it's definitely not A because there's no aldehyde present. It's not B because an alcohol would cause acidified potassium dichromate to turn green. And it's not C either because the secondary alcohol would do the same thing. So the answer must be D. Question number 31. Reagent X is added separately to 2-methylbutanol and 3-methylbutanol. The visible results are different. What is reagent X? So I've drawn out the structures right here. Option A is sodium. Well, it's not sodium because for both, hydrogen gas is going to be produced. You'll have observations of fizzing and effervescence at both. Option B, we'll come back to that in a bit. Option C, it's not option C because when we add PCl5, we'll have hydrogen chloride gas fumes evolve at both. So we'll observe white fumes, so there's no visible change. And acidified potassium manganate, we will also have the same observations. These are all due to the presence of the alcohol group. So this will, for example, to go from purple to colorless. Now for B, alkaline iodine is an indicator that we're referring to the iodoform test. We're going to have a negative result here, but we're going to have a positive result here, and that is because with 3-methylbutanol we have this group right here. And so the results of the visible changes are going to be different, so the answer must be B. Question number 32. Compound Y is hydrolyzed by warm aqueous silver nitrate to form a precipitate that is soluble in dilute aqueous ammonia. Compound Y undergoes an elimination reaction to form an alkene. What is a skeletal formula of compound Y? So silver nitrate has the following formula. It forms a precipitate with all of these. However, the only one that is soluble in dilute aqueous ammonia would be C and D, so we can eliminate options A and B. Then it gives us further information, and it says it undergoes an elimination reaction. Now, the only one that is possible, the only compound that's possible for this to undergo would be C. Because in D here, as you can see, there's a lot going on here, and if you were to draw it out, you'll find that you can't actually form a double bond here because there are two methyl groups on this carbon atom right here, and that would make elimination impossible. Question number 33. Propanol can be converted into 2-chloropropane using reagent M followed by reagent N. Which row is correct? So this is quite standard, but the answer to this question is C. That is because we use a concentrated acid, any acid, it could also be sulfuric acid, to provide hydrogen ions, which will react with the hydroxyl group to form water, and then our reagent N would be HCl. The Cl is provided from here and not from chlorine for many reasons. Chlorine isn't as efficient. It can react with hydrocarbons, but we tend to use HCl. Question number 34. Skeletal formulae of 4 organic compounds are shown. Which 2 compounds, when separately heated with dilute sulfuric acid, will produce propanoic acid as one of the products? So I've named each of the 4 organic compounds, and if we take a look at each of them, well, for starters, propanol is not going to produce propanoic acid. It could be oxidized if an oxidizing agent is present, but there is no mention of such. Compound number 2 is ethyl propanoate. If dilute sulfuric acid is added, then ester hydrolysis would occur, and we would get ethanol and propanoic acid. Remember, it's split in half. So the part that's bonded to the oxygen, single bonded to the oxygen, is the alcohol part. With propane nitrile, we would get propanoic acid, as well as ammonium ions produced. And with the last compound, we'd actually get propanol and ethanoic acid. So I think number 4 was there to trip you up if you weren't so good at naming. Therefore, the only options that give us propanoic acid are options 2 and 3. Therefore, our answer must be C. Question number 35. 1-chloro-2-methylpropane and 2-bromo-2-methylbutane react separately with aqueous silver nitrate in ethanol. Both reactions proceed via nucleophilic substitution and a precipitate is formed. The time taken for 1-chloro-2-methylpropane to form a precipitate is T1, and the time taken for 2-bromo-2-methylbutane to form a precipitate is T2. Which row is correct? So we have the compound, its mechanism, main reaction mechanism, and the time taken for the precipitate to form. So as we go down group 17, because we have Cl here and Br here, those are the main differences between the 2 compounds. As we go down the group, the bonds formed with these atoms and carbon atoms are actually a lot weaker as you go down the group, so the hydrolysis rate is a lot faster. That means as you go down the group, the time taken for the precipitate to form is going to be a lot slower. Therefore, RT1 is actually going to be greater than RT2, so we can eliminate options A and C. Then we're left with the main reaction mechanisms. So compound 1, 1-chloro-2-methylpropane, is a primary halogenoalkane, while the other compound is a tertiary halogenoalkane. And it is a fact that all primary halogenoalkanes have an SN2 mechanism, while tertiary halogenoalkanes have an SN1 mechanism. Therefore, our answer must be B.